Visible?
Yes,
Hello.
ma'am.
So very good morning, one and all. Today we are going to start the chapter number 4 on plane wave atom media interface of a subject electromagnetic field theory. We have learned the first chapter related was Maxwell's equation. In that we have seen the vectors, we have seen the dot product, we have seen the cross products, we have seen all the laws which were related to the Maxwell, just like a Gauss's law, just like your Ampere circuital law and etc. Even we have studied the introductory and the basic part related to the electromagnetics. Whereas in the chapter number 2, the uniform plane wave, we have seen what is mean by the uniform plane wave. We have seen how the plane wave propagates. We have seen how the electric and magnetic fields are traveling in the space. We have simplified many numericals which were related to your the uniform plane wave. Even the pointing vectors, how we can calculate the average power, how we can calculate the what we can say the pointing vectors in the field of electrical, what we can say the electric and magnetic field. That also we have done many more numericals. We have simplified on that. The third chapter also we have seen many parameters related to your the what we can say the media interface. We have seen how the what we can say the propagation is going on. All the numericals which were related to that also we have seen. Even we have simplified all the transmission lines related parameters. We have seen the calculation related to the transmission line parameters. All these things we have seen. Now come toward the next chapter, that is related to your the plane view atom media interface. In this chapter we will focus on the main particular part or the content which is related to this chapter is nothing but your the what we can say the polarization. Okay, so we will see here what is mean by the polarization. We will see here what are the types of polarization. We will see here in the electromagnetic field theory or in the electromagnetics what is the role of your the polarization, how the polarization plays a vital role in this what we can say the electromagnetic field. Okay, that we will see here. So the word is very small, but it plays a very important role in the electromagnetics. So in the real world, what is the use, how that polarization affects that, all these things we will observe here in this chapter. So let me start the session. So while we are studying this, the plane wave at a media interface, so the polarization, so whenever the it comes in the mind of the polarization, so that is directly come in mind, that polarization of your the light. Okay, how the things are coming here, how we can observe the polarization while we are talking about the light, or while we are talking about the what we can say we are studying related to the electromagnetic or the natural light or velocity of the light, all these things. So now here we will see what is the polarization. First of all, we should aware, we should know what is the effect of polarization, what is mean by the polarization. So here few things are mentioned, few points are mentioned which is related to the polarization. So what is that? Polarization is a property of a waves that can oscillate with a more than the one orientation. So in short, you can say the polarization is nothing but the effect. Okay, it's a multiple effect, or the whenever the effect is going on the particularly on the waves. Okay, so you can say the one or the more than one that orientation is happen in the what we can say especially in the waves. So in the electromagnet we know very well the multiple waves happens in the electromagnetics, that is electric as well electric as well as the magnetic field. These two waves are travels in the space, and definitely there will be the propagation, and if the propagation is going on, the orientations are many more, oscillations are many more, so we can observe the effect of polarization in this wave. Okay, so in such a case, that is in the electromagnetic waves such as the light exhibits the polarization that we are aware. There are the various types of the waves such as the gravitational waves, Okay, the sound waves many more. Okay, so the sound waves in the gas or the liquid do not exhibit the polarization, even though that is a waves. Okay, sound is having the waves, but still in the gas or in the particular material, just like your the gas and the liquid, they never exhibits the polarization. So since the oscillation is important in the particular direction, whenever the wave is travels, whenever the electromagnetic waves are travel. So this is the major difference, how the wave can be propagate, how the rotation will happen, how the oscillation will go on. Not each and every wave will be the polarized. Okay, so here this is the one of the example, electromagnetic waves are the polarized. Okay, but the sound waves are not. Whenever they will enter into the gas and the liquid, they are not polarized. So see here the effect, or you can say the light as an electromagnetic. So if we are saying the light is acting or the playing the vital role in the electromagnetics, the waves are propagating in the form of the light. You can say so definitely that will be the polarized. Polarization is happening or going on in the electric as well as the magnetic fields. When both are combining, the rotation will happen, the oscillation will happen. And see here with the help of this figure, you can find easily how the one of the field is traveling, how other field is reflecting on that. So these two both are traveling on a particular direction, and both are one is if horizontal, other will be the perpendicular to that, or you can say the vertical. So likewise both waves are traveling okay in the space. Okay, one will be the magnetic field denoted by the B, one will be the electric field denoted by the E in a particular direction. That direction you can assume anything. So in the waves, if they are the traveling, so definitely we need to find out on which particular how much length that they are traveling for, or how much particular length that they are traveling. So in short, you can say the wave which we are traveling, the wave on which we are traveling. Yes. So here the case is nothing but your the wavelength is important here. So the wavelength in between these two waves that we need to find out. Okay. So other parameter is nothing but your the what we can say. Other parameter is nothing but your electromagnetic waves. In that how the wave will be propagate. Few highlights, few points are mentioned here. So what is that few points? The few points are nothing but the few points are nothing but the light is an electromagnetic waves. Okay, and it consists of the variation vibration of the electric field and the magnetic field. Okay, so the electric field and the magnetic fields are perpendicular to each other and in phase. Both are in phase, we know very well, both are in phase. Okay, and they are perpendicular to each other. Just we have seen in the one of the figure how they are even in the bottom also there is a figure. Okay, you can find easily, you can identify easily. So what is going on here, if in a particular direction, that is nothing but the Z. So definitely definitely one will be your the X direction and other will be your the Y direction, and the Z, if the both are meeting at a particular direction, so that time we can get it. Okay, so see here the red mark is nothing but your the one of the wave, you can see the electric field, and the green is nothing but your the magnetic field. Okay, and in this way these two waves are propagating. Fine. So see here the highlights. So electric field as well as the magnetic field, both are there, both are present, and they are perpendicular to each other. Okay, so EM wave is a travels wave. The speed of the EM wave is will be, we know very well the basic, the speed of the electromagnetic wave will be your 3 into 10 raised to the power 8, that we are aware from this one. Okay, so see here the another the electric field vectors, how the vector combination will happen, how the things will go on, how they are perpendicular and the horizontal to each other, how they can the direction of the electric as well as the magnetic field will be will be there. Okay, so that also that you can observe here. Fine. So in this case you can say you can observe here in the same figure which were in the previous case, only the you can observe the four directions, that is upward, downward, right and the left, and you can observe the electric and the magnetic field, how they can be traveled in the z direction, and how what will be the what we can say, effect of your the electric as well as the magnetic field. So in this way we can find easily, we can observe easily all the parameters which are coming here. Okay, so you can find easily, see here the direction you can find easily, you can find easily the vector combination, whether it's a z direction, ax direction, ay direction, likewise which coordinate system you can use, that is the Cartesian, spherical or the cylindrical coordinate system. So likewise we can observe easily all these things. So in the next is nothing but how the light will be polarized, and what is mean by the polarized and the unpolarized things. So that you can find easily by looking this the figure or the diagram. Okay, so see here what is going on. So polarized light is nothing but the vibration lies on a one of the single plane only. So see here, if one of the charge is there, one of the point is there, and on that particular charge the intensity or the electric field or the charges are moving from the one place to the another place on a particular only single plane. So that time you can say the light is polarized. Okay, the light is polarized. The same thing, same example we can take at a particular point, at a reference point, at a particular place, and the intensity is moving in a many directions. Okay, in a many of the directions, that is electric field moving in a many directions. So that time you can say, suppose the superposition of a many beams in the same direction of the propagation, but each with a drawn the polarization. See here how even though they are in the same direction, but they are moving away from each other, and they are initiating from the particular reference point. So at that time that will be unpolarized, they are moving in a different ways. So see here what are the methods of polarization of your the light. You can say polarizing the lights. So you can observe here easily, it is possible to transfer the unpolarized light into the polarized. Yes, by looking that figure also we can identify easily in which particular direction they are moving. Okay, we can observe easily. So polarized light waves are the light waves in which the vibration occurs in the single plane. The process of transforming the unpolarized light into the polarized light is known as a polarization. Okay, so in for, unit number 1 also we have observed how the rays can be passed. Okay, how the intensity will be occurred in the entire vacuum or the things, and we can find easily the single rays, the multiple rays, the intensity of one thing and the multiple. So that we can find easily with the help of that things, how the lights are propagating, traveling, or intensities coming there. So there are a variety of the methods of polarization. Okay, so here few listed here. By looking this figure also you can find easily how the vertical, how the horizontal polarization is going on, how the light will be reflected, how the light will be refracted. Okay, there are various way by which you can observe easily. See here the polarization by the transmission, the polarization by the reflection, the polarization by the refraction, and the polarization by the scattering. So there are various way by which you can observe easily how the light is polarized, how the waves are propagating. Okay, so like this. So in other case, how the polarization by the transmission line and how the polarization by the reflection. By looking this figure, you can identify easily what is going on. So what we are talking here, polarization by the transmission line. So we know very well in the what we can say, the sinusoidal wave which is traveling from the one point to the another point. Okay, on the transmission line. So what will be the case? The how the forces will be act, how they can be transformed from the one point to the other point, how the electric and magnetic fields are what is in the vertical and the horizontal direction, and how they can meet, how they can vibrate. Okay, so all these things we can observe easily by looking this one. See here how what we can say, the transmission lines are there from the one point to the other, how the waves are traveling on that towers on that transmission lines, that you can observe. Similarly, how the reflection and refraction takes place. Unpolarized incident light. See here, if on a one particular direction and these two waves are there, that is electric and the magnetic waves are there, how they can be on the particular sheet or the surface, how they can be touch and how they can be reflected, that you can observe easily. Here the continuous analogy form, the waveform is traveling, okay. The electric as well as the magnetic field both are traveling, but here in this case you can observe the rays are coming, the light rays are coming, okay, how they can be incident and how they can be reflected. See here, so unpolarized in the improper way they are coming, okay, the lights are coming in an unpolarized incident form on a particular sheet, on a particular surface, they are intensing, but they are reflecting once again but in the polarized form, okay. So this is the difference. A reflection of the light of a non-magnetic surface result in some degree of polarization parallel to the surface, that we can easily observe. Here the unpolarized, you can say, they are not in systematically placed, but here the polarization is happened, how the surface is there, which is the non-magnetic metallic material, okay. So here the you can observe easily. Similarly, polarization by the refraction and the scattering. So reflection, see, from this point we have seen, if there are two refracted rays are there and they are passing through the what you can say, the island or the spray, the crystals, okay, that time how they can be perpendicular to each other, what will be the orientation of that you can observe easily. If there is a prism, if there is a crystal, if there is a island or any other things, okay. So what will be the case of a refraction here? So one case is unpolarized light incident is here, here will be the polarized but reflected, and third is nothing but the refraction, the third case is nothing but the refraction case. Similarly, when the light will be strikes the atom of the material, okay, so it will be often set the electrons of those atom into the vibration. That vibration of electrons produce the own electromagnetic waves which will be radiated outwards in all the directions, okay. So which produce electromagnetic wave. This is nothing but scattering of, okay, so or a scattered light in a particular polarization. So just like you're the atom bombarding the vibrations, okay, all these things that will become in the scatter. The next part is nothing but the, you can say, the polarizing material, okay. So what will be the effect of what will be the effect of polarizing material that we can observe here. So polarizing material will only be allow the passing of the component of electric field parallel to the polarization direction of the material. So here I will be the total current. Okay, you can say I is a total current, whereas I0 is nothing on the particular sheet that current is passing. Okay, and on a particular charges we are interested to find out what will be the effect of polarization on which particular direction they are polarizing. So polarizing materials only allows the passing of that components of electric field, okay. So see here I is equals to I0, that is at initial, at a reference or that particular current, what will be the total current and that particular reference current if we are having the charges, and how the direction of polarization will be happen, okay. So maybe the vertical, maybe the horizontal, maybe in the inclined also. So there are a various chances if the circular in the circular form, if we want to observe the polarization, then definitely the angle will be different, definitely the wave which is reflected on that also different, one will be the vertical, one will be the horizontal, and the angle will be different according to that, okay. So see here the vertical forms, here the slanting forms of propagation, how the propagation is going on in the particular direction and at what particular angle, how much, that also you can observe. If my electric field intensity is E, at which particular direction how my wave is coming here. So we need to take care if the number of charges are placed and they are moving on a particular direction, what will be the effect of my electric field, what will be the effect of my magnetic field, at what particular angle they are changing their phase, that is important. How the polarization is changing, the direction of polarizer is changing, that we can observe here. There are a various natural real examples in the real world of your the polarization you can observe in the day-to-day life. So polarization in everyday situation you can observe even we are aware, but we don't know whether this is a polarization is going on, whether this polarization is happening in the real world, in the daily routines. So these are the figures, these are the pictures. By looking that, uh, so this photography can shows and compares. So the reflected, okay, reflected scene you can observe in the water surface of the this is the in the water. See here the if water is there and from upper portion the sky is there, how that the sky can be reflected on that. Okay, that also you can see, observe. So here without what we can say reflection is there, and other is with reflected, that also you can observe. So here by looking this figure, you can identify easily how the water surfaces has been removed by the use of the Polaroid filters. Okay, so that you can here without waters, here with waters, but water, and how the sky reflection you can observe easily. So this is the one of the things, and other is here also in this photography also you can compare one of the about the reflected glare scenes. Okay, so these are the two things here. Okay, in that you can observe the various equipments and the components are placed in the laboratory, in the cupboards, you can say the glass cupboards, you can say cabinet, you can say, and the panels of the glasses in the lab cabinets have and removed by the use of the polarized filter. Okay, so here what will be the effect, what you can observe easily, what is the changes of photos. These are the examples, okay, by which you can say the how what you can say the cause of your the light becomes a polarized depending upon the reflection. So this is also one of the real world or day-to-day life examples of your the fluoride sunglasses, the effect of polarization, or you can say the light, how that light will be polarized and unpolarized, or what will be the action of your the polarized with the sunglasses. You can observe here how the light will be reflected from the surface like a flat road, or the something is there, the waters, the other things, how many things are the vertical and the horizontal polarizing. Okay, so that you can observe day to day life, how the refraction and reflection is going on, how the rays are changing, how their colors are changing, how the unwanted things are going out, that you can observe easily. So this is also one of the examples. Example that is nothing but your just stress analysis. The polarized light is often used to stress the analysis of your the molded plastics. Okay, so this is the one of the example. By looking this one also you can identify what is the effect of your the light polarization, or what will be the effect of your the polarization of your, not only by considering the electromagnetic waves in the, but many in the cases that you can observe easily. Okay, so here also the how the light will consist of the various wavelength, because if you are saying we are observing the polarization of the wave, the light, or the electromagnetic wave, so definitely there will be the um, definitely there will be the wavelength. Okay, we need to consider that wavelength. Okay, so each wavelength, what will be the distance, how long they are polarized, that we need to observe, how the rotations are going and what is the difference between the angle, that also you can observe easily. Second is the polarization in the 3D movies also. So see here, if you are talking about the light polarized, or the simply we are saying the electromagnetic things, so definitely electromagnetic waves is in the 3D. Because of that only we are seeing the electromagnetics in the X, Y, and the other direction. We are observing all these things. The gesture technologies, the effect of that. That's why we are seeing the huge, tremendous applications of your the electromagnetics or the electromagnetic field theory. In that the 3D is important. We are observing in all directions all the effects which is going on with the help of the parameters, with the help of the vectors, with the help of many things. Okay, so here so polarization is often implemented implemented in the what we can say the production and the viewing of the 3D films when watching a 3D movies. That also you can observe easily what is going on, how the polarization 3D glasses, you can observe here what is going on with the help of that effect. Even the gesture technology is one of the example by which you can observe this TV and the effect of that glasses. Okay, so there are various ways or the images that you can observe in not only in the movies, in the films, and even with the help of the glasses, with the help of the cameras, the projected on the screens. Okay, so how the things with the help of this 3ds, how the vertical and the horizontal effect will be go on. Okay, so all these things are possible to observe, okay, with the help of this polarization and effect. Next is nothing but you are the seven segment LCD effect, polarization effect of your the 7 segment LCD. Okay, so see here the 7 segment LCD effect in the lightning, the positive electrodes, the how the crystals, how the sections are going on, and how we can, because we are observing directly this section, that is nothing but you are the 5 which is on the display. Okay, so here the polarization 1 effect, polarizer of a second effect, how the things are going on. Okay, so that is mentioned here. So how the positive electrodes are coming here, how the crystals is there, how the negative electrodes are coming, how the second time the polarizer, and finally we are observing this a digital display. Okay, so these are the effects by which you can observe easily what is the effect of your polarization. Similarly, in the transmission lines also, in the antenna designing also, in the macro views also, even we can observe easily the polarization effects. If we are having the transmitting and the receiving axles or the aerials or the rods or the poles at that time, what will be the effects of, we can observe here the how the electrons are oscillating, how the transmitting or the scanning scatterings are going on, how the electromagnetic waves they are traveling. Okay, that effect we can observe easily the magnetic field and the electric field, how they can observe, how they can oscillate, how they can travel from the one point to the another point. Okay, that is also possible, how we can receive the signals at the receiving point or the television of a receiving areas. Okay, so electron oscillation, so here the reflector reflection and how the cables, how the signals are coming here on that particular antennas, that we can observe with the help of these things. Okay, so here is one of the reflector is there in the previous days for the television. We can we can observe how the signals are coming, how the reflectors are receiving that signals. That is possible with the help of this reflector, with the help of this cable signal we can receive and we can transmit from this antenna. That is also possible. So here in the vertical transmitting aerial vertical electron oscillating results in the vertical polarization radio waves is mentioned here. Similarly, the maximum electrons oscillation in the receiving aerial is also achieved when the aerial is aligned to be a what you can say the parallel to that waves of electric field. Similarly, one of the example which is related to your the again the light polarization or the electromagnetic wave polarization, that is the sky blue. So we know very well there are various teeny particles in the atmosphere, just like the dust, clouds, and the air molecules in the microscope water and the droplets. Okay, so this is one of the examples in the scattering polarizations, how they are shorter, how wavelength can be found, how the blue light you can say is greater than longer than the wavelength red lights. Okay, that also fine. How the sunlight will be passes through the atmosphere, how the scattering is going on in the atmosphere in the overall things. That is a natural thing. So you can say we can find easily, we can observe easily the day-to-day life, the polarization effect. So this is also one of the example, natural example, real example, day-to-day life. That is nothing but your the sunset, which is for red. Okay, previously we have seen the sky in the blue form, so sunset in the red. So here at sunrise and the sunset, the sunlight enters our atmosphere and shallow angles travels for long distances before reaching our eyes. So this is also one of the examples of what the effect of your the light polarization during this long passes. Okay, so how the blue light is will be scattered away and how the virtually that sea coming to us, and how the sun is really red to orange of a wavelength. So at every moment the distance is changing, the wavelength is changing. We can observe the color shades, we can observe the changes, the polarization effects every time, every instant you can observe easily. So in this way we should know the various polarization types, how what will be the effect of that. So today we have seen the various types. Today we have seen what we can say, the effect of your the polarization, the types of your the polarization. Okay, and what is the how the polarization plays a vital role in the electromagnetic waves that we have seen. In the next lecture we will continue the how the polarization can be calculated